Gentlemen, today we are talking about section 6.5, which is proving triangles similar by SSS and SAS. Now don't let the title fool you. We're not doing formal two-column proofs. We are doing informal explanations explaining or proving or showing the triangles are similar. First, we're going to talk about SSS, the SSS similarity theorem. Since it is a theorem, there is a proof. It's on page 389 of your textbook. It states that if corresponding side lengths are all proportional, then the triangles are similar. Because remember, with congruent triangle SSS, we talked about all sides being congruent. But since we're talking about similarity, all the sides should be proportional. So that means the ratio of AB to RS should equal the ratio of BC to ST, and the ratio of CA to TR. All these should be the same because all the sides should be proportional. So if we can check all the sides, we can know if the two triangles are similar. So let's do an example for some practice here. Is either triangle DEF or triangle GHJ similar to triangle ABC? So looking at A, B, and C, these are color coordinated for this particular problem. So the blues match up, the greens and the reds. But let's start with our longest side, so 16. And let's choose our longest side in DEF, so 12. So we'll see how those two sides correspond. Our medium sides are 12 and 9. And our shortest sides are 6 and 8. And these should all be equal if our sides are proportional. So let's reduce them and see if they reduce to the same fraction. So 16 over 12, or 16 to 12, they have a common factor of 4. So 16 divided by 4 is 4, and 12 divided by 4 is 3. 12 over 9 reduces to 4 over 3. 12 divided by 3, and 9 divided by 3. And 8 over 6 reduces to 4 over 3. 8 divided by 2, and 6 divided by 2. So in this case, yes, they are going to be proportional, so by SSS they are similar. So I will say that triangle ABC is similar to triangle DEF. So our first pair works. Let's look at our second pair of triangles. Let me get this out of the way here. We're going to look at triangle ABC and see if it's possibly similar to GHJ. So again, we'll compare our largest sides, 16 and 16. We'll compare our medium sides, 12 and 10. And we'll compare our shortest sides, 8 and 8. Now, if you don't look at it as long, medium, and short, you can also just judge them by their orientation. You can see that these are reflections of each other. One is the flipped version, so 8 corresponds with 8 when they're flipped, 10 and 12, and 16 and 16. Well, looking at our ratios here, you can already see that they are not proportional. This is 1. This is 1. But 12 over 10 is definitely not 1, so we don't really even need to go any further. We can just say, no, not going to be similar because the sides aren't proportional, so we don't have SSS. We don't know any angles, so we can't use AA. And in this case, it wouldn't matter because these are not proportional, so the angles aren't going to match up anyway. So let's try something else. Find the value of x that makes these two triangles similar. Well, if they are similar, then sides are proportional. So that means that 4 to 12 is the same as x minus 1 to 18. And you can also say is equal to 8 over 3 times the quantity x plus 1. But since we're solving for x, all we need is a proportion with x in one place. So we really don't even need to worry about this for writing a proportion. We can just use what we already wrote and cross multiply. I'm going to reduce this fraction so that I'm cross multiplying with smaller numbers. So 4 over 12 reduces to 1 over 3. So let's cross multiply with our smaller fraction. So 3 times x minus 1 is 3x minus 3 when I distribute. And 1 times 18 is simply 18. And if I solve my equation, x ends up equaling 7. And if you plug 7 in our other expression, you'll see that 3 times 7 plus 1, or 3 times 8 is 24. And 8 over 24 also reduces to 1/3. So it all checks out together. The second way to determine for today if two triangles are similar is the side angle side similarity theorem. which is very similar to the side-angle-side congruence theorem, or congruence postulate. For the theorem, we have two pairs of sides that are proportional, and the included angle as well are going to be congruent. So if these two angles are congruent, we should know that these sides are proportional, and these sides are proportional. So we have proportional sides, and the angle is in the middle, something that's like SAS. And you can take the time to read this theorem yourself. I just paraphrased it for you. It's also in the textbook, but I'm not going to keep this on this page too long, so we can do some examples and keep this video short. So, tell what method you would use to show the triangles are similar. Well, in this case, we have two pairs of sides that are listed, so we can't use side, 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 but we do have vertical angles here. So we would check to see if these are proportional, and these are proportional. I'm sorry, we should check and see if these are proportional and these are proportional. And then we have vertical angles. So what method would we use? SAS. Does the problem ask us to actually do it? No, it just says what method would you use. So actually all we would need to say here is yes, we would use SAS, and that's our answer. And finally, explain how to show that the indicated triangles are similar. So I'm just going to talk you through it without actually doing it because it says explain, not actually do it. So how would I show these are similar? Well, I have a pair of congruent angles, and then I would check to see that my sides are proportional. So I would check to see that 4 over 18 should equal 28 over 21, and that's it. I don't have to do it, it just says explain how you would do it. For number 4, I have two triangles within a larger triangle, and I'm trying to show that XWZ, or XDW, is similar to YZX. So this one over here. Well, I have 3 pairs of sides in both of them, so I can use side, side, side. It'd probably be the easiest way to do it. So if I compare my longest side, which is 20, it corresponds to my longest side, which is 15. If I can choose my medium side, which is 16, it corresponds to my medium side, which is 12, because this triangle is a flipped version of this one. So if you, let's see if I can do this here, it'll let me. Oh, it won't let me do it. But if I were to take my green triangle and rotate it to the purple one, you would see that 12 will line up with 16. Those are corresponding. And then your shorter sides are 12 and 9, because 12 corresponds with 9 if I were to rotate this. So I should check and see if all these are proportional, and then that'll tell me by side, side, side if my two triangles are similar. So that's just a very, very brief, short recap of the lesson. There's lots of problems you can look at in the textbook and work through examples and ones from class. So hopefully this brief video is a bit helpful.